Okay, I'm just going to run through some of the questions that you might see in your 11.5, 11.6 homework. So we're talking about permutations and combinations. So permutations are orders of things or ways of arranging things. And combinations, with combinations, order doesn't matter. And it's how many ways you can do things. Okay, and so we'll get into quite a few of them. First thing, you need to be able to use your calculator. And so something like this on your calculator, just look for um, the NPR button. So if you look anywhere for an NPR, make sure you don't do the NCR. That's for combinations. That'll be later. But this is a PR button. Sometimes you have to put a 12 in first and then type the NPR button, then hit a 12 and then press enter. On my calculator, I hit the NPR button and then in brackets I have to put 12 comma 12. So there's different ways that you do that. Anyway, if you do that, I think that comes out to 479,001,600. That's a huge number. And that's if you have 12 things, what they're asking there is how many ways you can rearrange those 12 things. And it'll be that number there, 479 million, etc. Here's another calculator question, 0 factorial. That's how many ways you can arrange 0 things. And I guess, and if you try that on your calculator, sort of interesting, it comes out to 1. Okay, so here's an actual question. It says, how many permutations are there of letters of the following word if all the letters are used without repetition? So no repeating. If they're repeating, then it'd be, I guess not too hard, but anyway, if all the letters are used, so how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 letters altogether. Are there any that are reused? It looks like there's no doubles. So if I'm looking to see how many ways of rearranging those, I would just say 8 things, and I'm rearranging them, and I'm using all 8. So on your calculator, if you go 8, pick 8. Let me do that. 8, pick 8. Go. 40,320. 40,320. Okay, next question. Identify which notation properly depicts the solution to this problem. Select all, apply. Oh, I guess I already figured out the question. It would be that one right there. Now, another way you can think of that, and I want to pick this answer as well for this. Oh, and I want to pick this answer too. Is that all of them? Yeah. So if I have 8 things and I want to know how many ways I can rearrange them, another way to do that is using the fundamental counting principle. So there's 4, 5, 6, 7, 8. And ask myself how many things could I put in the first slot? If there's 8 things, 8 letters, then there's 8 that I could put there. If I can't repeat, then the next one, I'd only have 7 left, then the next one 6, etc., all the way to the bottom. And the fundamental counting principle says, figure out the number of ways to do each thing, and at the end, you multiply all those. Okay, so that's what that is. Another way of writing that, rather than having to write 8 times 7 times 6 times 5, notice how it keeps going down by 1. Another way of writing that is just 8 factorial. So that, this, and this all mean the same thing. Okay, a program is planned to have 6 musical numbers, 6 speeches. In how many ways can this be done if a musical number and a speech are to alternate and a musical number has to come first? Okay, well, I can use fundamental counting principle. I guess I could do a couple of different things. So there's musical number, speech. Music, speech, music, speech, music, speech, music, speech. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Music, speech. Okay, so if I have 6 musical numbers, there's 6 that I could put there. And then 5 could go there, because I have to have a speech in the next one, right? 4 could go there, 3 could go there, 2 would go there, 1 would go there. Similarly, if you look at the speeches, I'd have 6 that could go there, 5 there, 4 there, 3 there, 2 there, and 1 there. And then fundamental counting principle just says multiply them all together. Now, since I have 2 runs of 6, what I would probably just do is say it's 6 factorial times 6 factorial. And you can do that on your calculator. Okay, do that and that'll come up with your answer. Okay, next question. How many code symbols can be formed using 3 out of the 6 letters? Oh, so codes. So the first one is different than the second one. So how many, if the letters are not repeated? Okay, so I've got to use 3 of the 6. So 1, 2, 3. So they can't be repeated. So I could have, how many letters are there? 1, 2, 3, 4, 5, 6. So there's 6 that could go here, 5 that could go there, and 4 that could go there. That would be A. Okay, B, what does it say? Oh, they can be repeated. So again, I have 3 slots. I can put 6 in here, but if I can repeat, then I've got 6 more to put in there. And if I can repeat, I can put 6 more there. Okay, C, are not repeated, but must begin with a D. Okay, so 1, 2, 3. So my only option for the first slot has to be a D. Okay, and not repeated. So if they're not repeated, so I can't use the D, so I only have 5 other letters to put there and 4 letters to put there. So the D, that's one thing I can put there, times 5 times 4, there'd be 20 things. Okay, and D, it has to begin with a DE. Oh, so D has to go here, E has to go here. So there's only one thing that can go here, one thing that can go there. And then there would be, if I can't repeat, then I'd only have 4 letters left to use. So it'd be 1 times 1 times 4. Okay, what is the answer using the proper notation? Oh, for each part, give the answer using I sort of did that. What is the answer using the proper notation? For which question? Oh, it's A. Oh, so A is 6 times 5 times 4. Where's that? I don't see that. Oh, right here. So I have 6 things, and I'm picking 3 of them. So there'd be whatever that is, 120 about. What is the answer in the proper notation for B? Can be repeated, so it'd just be 6 times 6 times 6. Where's that? 6 right there. 6 cubed. That's sort of an awkward one. Okay. And for C, it was 5 times 4. So where's 5 times 4? Oh, maybe it's this one right here. So right there, right here, there's one thing that could go in the first spot, and then there's 5 things left, and from them you have to pick 2. So that would be that one. And then D, what was D? They have to begin with a DE. So it'd probably be that one right there. So 1 in the first slot, 1 in the next slot, and then you have 4 left, and from them you have to pick 1. Okay, next question. Solve the following for n. N, P8 equals 8, n minus 1, P7. Oh, that's an interesting one. Okay, so we're doing P's here. 8, n minus 1. Now there's a formula for permutations, and if you have n PR, that's equal to n factorial over n minus r factorial. Okay, where n is the first thing and r is the second thing there. So if I do that with this, just that information there, it'll be n factorial over n minus 8 factorial. Okay, and they say that's equal to this. So let's do the same thing with that. So on the top I'll have n minus 1 factorial over on the bottom is going to be n minus 1 minus 7 factorial. So on the bottom, that's interesting. So on the bottom, okay, I'm with it on this one. I forgot this 8 right there. So that 8 should go right here. 8, and then n minus 1 factorial. Yeah. So because that's 8 times this stuff. Okay, so I'm just going to keep going down from here. So this would be n factorial over n minus 8 factorial. Over here I have 8 times n minus 1 factorial all over n minus, this will come out to 8 factorial. So the bottoms are the same. So if I multiply both top and bottom, by n minus 8 factorial, n minus 8 factorial, they cancel and those cancel. So I'm left with n factorial equals 8 times n minus 1 factorial. Now n factorial, any factorial, just means take n and then times it by whatever n minus 1 is, and then times it by n minus 2, and keep times in it and just keep going down by 1 like that. So if I start that with this one, I'd have n times n minus 1, and I'm going to stop right there because on the other side, I already have that n minus 1 factorial. And so rather than going n minus 2, etc., I'm just going to say factorial. That means go on forever. And then on both sides, I've got n minus 1 factorial, so I can divide both sides by it. They cancel out. N comes out to be equal to 8. I don't like that question. Don't worry about that one. All right, the next question, 9 choose 5. That's just a calculator question. Let me get my calculator going here. And functions, I want NCR this time. And I've got to go 9, comma 5, 126. Okay, now this here, 20 and 6 below it, that's just another way of writing 20 choose 6. So the big brackets like that are just another way of writing 20 choose 6. So if I do that on my calculator, 20 choose 6, I come out to 38,760. Just a calculator question. Question 9 is similar to this one up here, which is evaluate that. So that's just saying n choose 1. What is that equal to? And it says evaluate any numerical factorials. So I can use my formula. This is the NPR formula. There's a CR formula that looks like this. So I'll just write over here. So n choose R will be n factorial over n minus R factorial R factorial. Okay, so if I plug stuff in here into that formula, it would be n choose 1 is equal to n factorial over n minus 1 factorial 1 factorial. 1 factorial is just 1, so it goes away. And now if I look at the top here, that n factorial, same thing as I did up here, I can start expressing it. So it'd be n times n minus 1 times n minus 2, etc. That's what that factorial means. But on the bottom, I have n minus 1, and if I subtract 1 from that, I get n minus 2 forever, and I keep going, I can just put a factorial there. You see what's going to happen with the top and the bottom? Those cancel, those cancel. So my answer in the end would just be n. Okay, next question. In how many ways can nature select 4 students out of class of 18 to get the flu? So they're choosing, so it doesn't matter what order these students get the flu, it's just that they get it or not. And so you'd say I have a total of 18 students from which I'm choosing 4. So 18, choose 4 on my calculator here. 18, come on. 18, choose 4. 3,060. Now it's important that it's a choose. If order's not important, it's a choose. If order's important, then it's a pick or a permutation. Okay, last couple questions. Given an expression for the answer using permutation combination of the first 9 questions on the test, the student must answer 7. Does it matter what order they come in? Doesn't. So I would say that first part would be a 9, choose 7. Then of the second 6 questions, the student must answer 3. So there'd be 6, choose 3. Again, it doesn't matter what order. So I've got a set of 9 questions and I've got a set of 6 questions. So I have to choose 7 in this one, I have to choose 3 in this one. So what I do is I just figure out this individually, figure out this individually, and then I multiply the responses. Now chooses, remember that formula from the last page, it would look like this: 9 factorial over 9 minus 7 factorial, 7 factorial. That's that one. This one would be 6 factorial over 6 minus 3 factorial, 3 factorial. And I'm multiplying those two. So I just have to look for something like that. This one looks pretty close to exactly that thing right there. Oh, and it says select all that apply. Oh, here's another one that would apply. That's exactly what I have up there. 9, choose 7. Oh, no, that's pick. No, not that one. Oh, here it is right there. 9, choose 7 times 6, choose 3. Yeah, that's it there. Okay, and I don't think there's any other ones that would apply. So it's just those two, D and L. Okay, question 12. 18 students in a fraternity, and how many ways can a committee of 4 students be selected? Oh, there's 18 people, and from them I want to choose 4. Does it matter what order they come in? No, it's 18, choose 4. Do that on your calculator. How many 2-card hands are possible with a 13-deck card deck? Okay, how many total cards are there? 13, and I'm wanting to choose 2 of them. Do that on my calculator. Done. Hopefully that helps you with those homework assignments for 11.5 and 11.6. Make sure you've watched the video, because I go through quite a bit of this kind of the theory of permutations and combinations there. These kind of questions where they use the formula, I'm not too worried about those. I'm more worried about questions like these at the end, where you can identify if it's a permutation and a combination, and then choose the correct formula to finish it off. All right, hopefully that helps you.